Right, and I did a simulation to help with our project right over here. It's to simulate how a rocket takes off, and I wrote it in Java, and so you can see that I'm using the left and right arrow keys to spin the rocket back and forth. The spacebar will fire a rocket, so it's similar like a rocket that's like a probe that's launching out, and it draws these little dots on the screen to show the path of the rocket. So on the right hand side right over here, it can show the altitude, the x position, and the y position, the x velocity and the y velocity of how the rocket's traveling. So you can see that it's changing over and over. The firing speed can also be changed by increasing it through hitting the S key and decreasing it through the A key. The lowest is 0 naturally, and the highest is 50 with speed. The object of this game is to try launching the rocket and hitting a moon target that randomly appears on the screen. And up here, it'll tell you the statistics. The first number will tell you how many rockets have you launched, and the second one will tell you how many rockets have actually hit the moon successfully, and it'll calculate a percentage rate to launch it.
Right,
so for example,
a certain amount of rate. Yeah, so there is a way to do it.
I'm doing really bad right now, but if I hit a moon right here,
you might need to have more switch blocks because you don't get a single power out that way.
And update my percentage right over here. So that's my simulation, and we're using this in Palo Alto for Steve's workshop to demonstrate to the kids how does a rocket launch and trajectories and sort of like basic vectors.
And then
alright, start recording, so whenever you're ready.
25.
This is a catapult I built. The purpose of this ball is to support what the kids learn from the Moonbots takeoff program, which is that depending on though the speed doesn't change, instead of changing the speed like in Brian's program, you change the starting position of the object.
Alright, so I'm Calvin. What I did for our presentation was the lunar lander simulation. So basically, this was to help the kids understand the process, of landing a probe. So then, basically, they would use the thrusters to try to stabilize and slow down the probe so that it could land safely. And then they would deploy a rover, which would collect samples of helium-3 and water ice samples, and then return to the probe and lift off. So this was to just give them a better idea of what happens in reality when scientists need to go retrieve samples from the moon or Mars to study them and to get a better understanding of that.
They are a Google Lunar X Prize Moonbots team. I'm Brian, I'm the team leader for our team. We're Team 2011 Lego Odyssey. That's our team name for Moonbots competition. And this is...
My name is Anthony. I'm a friend of Brian, and I chose to join the team this year because I met him in high school, and he's very good at what he does.
And we got the last member.
I'm Calvin. I also joined because I knew Brian. He was in my computer science class, and so I thought this would be a good experience, and it's pretty fun.
Okay, so the first thing we'll talk about is, well, what the heck is Moonbots anyway? So, here we go. Moonbots, you go design, build a robot. It's sort of like first Lego League. You have a field of Lego, and you have to build and design a robot to complete all the missions by itself.
You get to benefit from the fundraising that Google and Lego have done to give you the resources you need to be able to compete in the competition.
So the arm's gonna cut like this, and let me see. Okay, here we go. Then it's gonna drive forward. I'm just gonna put it off, I don't wanna drive it. And I'll throw the loop at all times. Here it is again.
That was every turn. That's right?
Yeah.
Go! Oh, awesome!
With their engine at the back and their fuel at the front, they can only fire in one direction. Adding entire rockets to something is very expensive. What you want to do is use one rocket instead, and simply use that one fuel source and as few engines as possible.
Yes, see how many fuel tanks are in that thing? Fuel tank, bottom. Fuel tank, middle. Fuel tank, up there. And the people, the astronauts are all at the very top. That's it. Can you believe that? And almost the entire rocket is fuel tanks and an engine. rockets apply the force that they have. They don't, they shoot diagonally all right, but they apply a force going horizontally and a force going vertical.